Hello everyone. In this video we are going to talk about logical and comparison operators and also creating logical arrays. Now that we know everything about arithmetic and arrays, it's time to talk about logical arrays and creating logical values. So in the next video we can talk about the decision making. So here, since I need arrays, I import the module numpy, rename it to np, and also use math if I need to do math operations. So here I have three values, and first I use comparison operators to create some logical values, and then I can combine them using and, or, and not. So if you want to and, or, and not single logical values, Boolean values, you use exactly and, or, and not. You just type the word and, or, not, okay? Comparison operators you have are bigger than, less than, bigger than or equal, less than or equal. They are if they are equal, and then not equal. So not is basically an exclamation mark, and what? The basically equal sign. So these are comparison operators, okay? So here, if I say x bigger than y, well, of course, x5 is not bigger than 6, so that's false. And z not equal to x, of course, -2 is not equal to x, so that is true. So this is a false and a true, which the result is, of course, going to be false, as you can see. The next one is x bigger than or equal 5, which is again false. Z not equal to x, that's true. So this time we have or between a false and true, which is going to be true. The next one is z equal to x, which we know is false, but not of a false is true. And finally, we have x less than y, which is true, and then z less than or equal x, which is also true. And here, this is a separate operation. This operation is XOR. So please pay attention here. If the two sides of this exclamation equal, if the two sides of it are numbers, then that is a comparison operator, means not equal to. If the two sides of this operator are Boolean values, then this guy is XOR. Because we don't have the word XOR like we do have and, or, and not in Python. We don't have a word called XOR, but we can do it with this exclamation equal that does the job. And here we have a true XOR true, and you know true XOR true is false, and this is what you will get here. Okay, so again we have the same thing doing two different jobs depending on what operand we are passing to it. Numbers, it's a comparison operators, mean not equal to. Logical, it is X or. So please keep attention to that. And this is the first part of the code. Now, if we are dealing with logical vectors, which means a vectors of only ones and zeros, a vectors of Boolean values, that we call a logical array or logical vector. We can create those and we can perform operations on those. So for example, here, let's say I use the np arrange command and create a bunch of numbers from 0 to 9 with an instance of the space or step of 1, right? You know, that's np.arrange 10. So these numbers. Now I say, hey, show me vector, but also show me where in vector 1 the values are bigger than 4. Wherever it's bigger than 4, place a true. Wherever it's less than or equal 4, give me a false. And this is exactly what it does. So for 0 to what? For 0 to 4, which are not bigger than 4, these 5 entries, you get 5 falses. And then from 5 to 9, these other 5 entries, which are bigger than 4, you get what? You get 5 trues. So you see, by comparing an entire vector against a single number, I can get a vector of trues and falses, which we call a logical array. Now, if we want to perform logical operations between the logical arrays, we cannot use and, or, and not the way they are written over here. These and, or, and not are only for what? For a single value on their left or right side, and not is a unary operator, so it just needs one. If I have a vector on one side and a vector on the other side, I cannot use and. It is and, but I cannot type and. I have to use the and that you are familiar with in MATLAB or C++, the ampersand. And I have to use this vertical wall, basically, right? This vertical ladder that is OR between them. And for not, I have to use tilde. Okay, so please pay attention. And, or, and not for logical arrays are going to be ampersand, this kind of a line, right? Vertical line, and then tilde. So this is how we do it. If I use and here or here or not here, I am going to get an error. And the reason that Python gives you is, hey, for using and or and not with logical array gives you error. Why? Because it says the logical error is ambiguous. The value of it is ambiguous. What does that mean? It means, hey, if I give you this, and I'm asking for a single number out of this whole vector, what should I give the AND operator? Should I give it true or false? Well, clearly I cannot give any of that because it's an array of all of those. And again, remember, AND needs one number on left, one number on right. But if you have a ton of numbers on left, which one of them does it pick? It doesn't know. So we say it's ambiguous, and that's what it does here for you. So if you want, I can add something for you and say and not, or only work on single logical variables. On a single or two logical variables, okay? So if it's and or, just two, and if it's not, just on a one logical. But for vectors, we use those operations, those symbols. Now let me show you some further operations on logical vectors. So here I create another vector, and this time this vector has complex numbers in it in general. And for complex numbers, we can clearly use j, right? So 1 plus 1j, 1 plus 0j is a complex number. The interesting part is there is no star that you need here, right? As we've seen in the previous video, no star is needed. We can simply say 1 plus 1j, no star between 1 and j as you do in MATLAB. Okay, and you might be tempted to say, well, what about I? Can I use I like I do in MATLAB? You see, I and j are the same thing for complex numbers. If I do that for Python, would that accept it? And you see that it does not. Okay, so j is only used for complex numbers, not I. And again, as I said, you do not need asterisk, but if you put that there, would you get an error? And let's take a look here, and you see, yes, you do. Okay, so if you want to define a complex number, make sure that, let me add that here, only j, not I, to be used, and no asterisk, right? You don't need any of that for a complex number. Otherwise, you can easily ruin your calculations. So now I get that complex vector, fine. Now there are some logical commands that when you pass, it gives you a logical vector. So not only you can create logical vectors by comparing a vector against some number, right? By comparison operators, there are some commands that you can apply to an entire vector of numbers, and that gives you a logical array. One of them is real and is complex. Right, so it says, is the whole thing real or is the whole thing complex? So let's take a look here. So we are right here, right? Is real, which one of them is real? So is this guy what? The first one, 1 plus 1j. Is that a real number? Well, clearly it's not, it's false. The next one, which is 1 plus 0j, since the j is 0, then it's true. The next one is 4.5 plus 0j, again is true. The next one is 0.2 times j. Let's see. After 4.5, there is 3, so it's true. Then we have 2, which is true. The last one is 2j, which is false. Now pay attention to this part, that is also interesting. These numbers are not complex numbers, but since we said all of these guys are of type complex, when Python is displaying them, it adds a J component to each and every one of them. But how much is J? That is 0. Okay? So if there is no J, it is adding a 0J, so it is doing a typecasting here for you. Okay, so you see, I completely converted my complex vector in what? In a logical array. I can do the opposite of that, which is complex, and you see it's exactly the opposite of that, right? Wherever it was false, now it's true, and vice versa. So I could create is real and is complex using a simple not operation. The other thing I can do here, I have created two vectors, right? 4, 2, and 1, 2, 2, and 2. And then there are some other operations under the NumPy module that I can use again to create logical vectors. And these are similar to what? These are simply similar to these comparison operators. And the good thing is you can compare vector and vector here, not compare a vector against a number. So here I'm comparing entire vector 1 with entire vector 2 and say greater equal. So basically it checks each number here. Is that greater or equal than this number? Yes, so that's true. Is this one greater than or equal? Yes. Is this one? No. So you should get true, true, false. And this is exactly what you would get over here. Right? And in order to be able to do this operation, both of these vectors, of course, have to have the same size. It's obvious. Instead of greater than or equal, I can do less than, right? And then again, it do less than. So here you should get 2 falses and 1 true, as you can see here. Then I can do equal. Which one of them are equal? Should only get a true in the middle, as you do here. And then I have not equal, which is the opposite. 2 trues on this side and a false in the middle. So you see I have greater, equal, greater, less, less equal, not equal, equal, right? So in addition to this, I also have what? Of course, I have NP and then greater. I don't need greater, equal. And this one is less, so I can also have what? NP less equal, right? That is doing both sides. Finally, there are some other things that we can do, and these two other commands that create logical vectors, and they are comparing the entries against nan and inf, sorry. So here I'm creating a vector, and this time my first entry is a nan, which is not a number. The second one is 2, next one is complex number, next one is infinity, 0, and -3. And this is where, by the way, you need the math module, because otherwise you cannot define the constant math inf or math nan. So you see, these are the two places that I need that module. And then if I run the command is nan, then only this guy should be true. And if I run is inf, then only this guy should be true. And this is exactly what you can see over here and over here, right? Finally, there are two other commands that I thought they are might be very useful to you. One of them is called the command all. The other one is called the command any. So what is all doing? All checks for a vector x whether all of the entries of x are true. So if everything in vector x is true, then the result is true. If even one of them is false, the result is false. So here I say on this vector is inf of b, which is this guy. Run np all. Do I have all of these values true? Well, of course not, so the result is false. On the other hand, any checks whether any of those entries is true. So even if one of them is true, the result is true. And of course, because I only have one here that is true, the result of if any would be what? Would be true. Okay? So you see I have all of these different NP operators. Any, all, is, nan, is, inf. Less than, equal, greater, equal, non-equal, is complex, is real. All of these logical commands, as well as all of these comparison operators, can give you what? Can give you logical arrays, and this is how you perform and or not on them, and these are how you perform and or not on single values. Okay? So hopefully this video is useful to you, and I will see you in my next lecture. Thank you.